Hello and welcome back to the channel. If you're looking to turn your physics knowledge into flawless exam execution, you're in the right place. In this video, we are breaking down a 9-mark gravitation question step by step. We'll cover field strength, orbital periods, and how to use a simple logic ladder to conquer the tricky evaluation questions that trip up the vast majority of the state. To calculate the gravitational field strength at Pluto's surface, we assume Pluto is a uniform sphere. Under this assumption, its entire mass can be treated as if it were concentrated at its center, meaning the distance from the center to the surface is simply the radius of Pluto. By substituting the values for Pluto's mass, this radius, and the universal gravitational constant, g, into the gravitational field strength formula, we can determine the final value. To calculate the orbital period of Charon around Pluto, we assume that the only significant gravitational interaction is between these two bodies, and that Charon's orbit is perfectly circular. Under these conditions, the gravitational force acts entirely as a centripetal force. This allows us to use Kepler's third law relationship by substituting the mass of Pluto, the orbital radius of Charon, and the universal gravitational constant, g. Because this rearranged formula is not explicitly printed on the standard VCE formula sheet, students are strongly encouraged to write it down on their summary sheet for quick reference during exams. Scientists wish to place a spacecraft of mass 1,000 kilograms in an orbit of the same radius as Charon. 3 students, Rick, Melissa and Naam, are discussing the situation and have different opinions. Rick says as the spacecraft is lighter, it will have to move at a greater speed than Charon to achieve the same orbit. Melissa says the spacecraft would need to move at the same speed as Charon. Naam says the spacecraft would need only to move at a lower speed, as it is lighter than Charon. Evaluate these 3 opinions. Detailed calculations are not necessary. 3 marks. When facing a 3-mark evaluation question like this one, it is incredibly easy for students to slip up. In fact, VCAA examiner reports show that 51% of students scored 0 marks on this exact question. Let's break down the precise structural logic needed to secure full marks, followed by a model answer, and the main pitfalls to warn your students about. The logic ladder. To score full marks on a VCE, evaluate the opinions question, students must systematically climb these 4 rungs. The verdict. State immediately and unambiguously who is correct and who is incorrect. Hedging bets or saying everyone is a little bit right results in an instant loss of marks. The physics principle. Identify the governing physics framework, in this case, that gravitational force provides the centripetal force. The algebraic proof. Show how the mass of the satellite cancels out of the equation, proving that velocity is independent of the satellite's mass. The contextual link. Explicitly tie the math back to the prompt, concluding that the spacecraft must travel at the exact same speed as Charon. Full mark model answer. Melissa is correct, while Rick and Naam are incorrect. For a stable circular orbit, the gravitational force acts as the centripetal force. Solving for orbital speed yields. Because the mass of the orbiting body, m, cancels out, the required speed depends solely on the mass of the central body, m, and the orbital radius, r. Since the spacecraft shares the same orbital radius around Pluto as Charon, it must travel at the exact same speed as Charon, regardless of its lighter mass. Major pitfalls to avoid. The hedge betting trap. Many students try to validate every student's opinion, e.g., Rick is right if we talk about momentum. Assessors explicitly state that marks cannot be awarded if it is unclear whether the student recognizes an incorrect argument. Right conclusion, no justification. A massive portion of the cohort correctly identified Melissa as being right, but could not provide a valid mathematical reason why, leaving them capped at 1 out of 3 marks. Confusing mass terms. Students frequently fail to specify which mass cancels out. They must explicitly state or show that it is the mass of the satellite, m, that cancels, while the mass of the central planet, m, remains critical. Key physics results. Q4A Gravitational field strength. Treat Pluto as a uniform sphere, so its mass acts from the center and the distance is the planet's radius. Q4B Orbital period of Charon. Gravity supplies the centripetal force, so Kepler's third law links the period to Pluto's mass and the orbital radius. Q4C Orbital speed of the spacecraft. The satellite's mass cancels, so speed depends only on the central mass and radius. Melissa is correct. Key exam takeaways. Climb the logic ladder. State a clear verdict, name the physics principle, show the algebraic proof, then link it back to the question. Avoid the common traps. Don't hedge bets, don't state a conclusion without justification, and specify that it is the satellite's mass m that cancels. Why it matters. 51% of students scored 0 on Q4C. A clear, structured argument is what secures full marks. If you need my help, you can add me on WeChat or WhatsApp, or send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.